What's going on, guys? It's Cooper Codes, and in this video we are going to create a URL shortener in Apollo server, GraphQL, and MongoDB. We're going to start by explaining the backend infrastructure of URL shorteners and how they work. Then we're going to implement Apollo server alongside MongoDB with mongoose. We're then going to create Apollo server logic for visiting shortened links and creating shortened links. Then we're going to test our Apollo server and look at how the MongoDB changes as we do things like visit the link and also create new links. Let's get into it. Before diving into the code, let's take a look at the system we're going to create throughout this video. So we're going to have an Apollo server with two main functions, creating a short link and then visiting a short link. For example, if a user wanted to create the short link for thecoopercodes.com, what would happen is we'd call our Apollo server and the user would input thecoopercodes.com. And with that input, we would go over to the logic for this Apollo server function. First, we're going to see if we already have a short link for this URL. You could imagine if a bunch of people saved a short URL for google.com or something. You don't want to have a bunch of those. You want to see if you already have a URL like that in your database. And so let's say we're the first people to ever save a link for thecoopercodes.com, for example. We're then going to create a unique ID which represents thecoopercodes.com and store the original URL and the short URL in our database. At this point, we've created our short link. We can show the user created ID, and then people can access thecoopercodes.com by saying shorturls.com/your ID. That's one of the main concepts, is this ID you can find by looking for the URL that you've stored in your database. So you can imagine if your ID is like 6 characters long, but the URL was like 50 characters long, you're going to have a shorter URL, for example. It's also important to look at how we visit short links. So if we were to visit shorturl.com/ID_here, and let's say this is the ID that represents this Cooper Codes domain up here, we can check if ID_here exists in our database. If so, we can give the front end the full link. So for example, the user inputs ID_here by saying, shorturl.com/ID here, and then we are going to give them thecoopercodes.com. That's the basic functionality as to how a URL shortener works. We can also do cool things like whenever they visit a certain URL, we can keep a count, which is something we're going to do in this video. We're going to count how many times a certain domain has been accessed through our short URL service. Before we start coding, let's get into setting up MongoDB. To set up our MongoDB database, we are going to use MongoDB Atlas, which is something I've used in a bunch of my videos. It is a fully managed database, which means you don't have to do any of the setup yourself. It's just going to give you a link at the end that we can use for our Apollo server. So sign in. So once you're signed in, you might be prompted with a different page to immediately make a database. But if you're at this page, go to build a database here. This is the page you might get prompted with initially. So if you're here, you want to go to the free option. And I always say this in my videos, you're not messing up if you're getting it for free. So if you're doing the free route, you're going to be fine. There's only one way to get it free. Choose the region that's closest to you, and the cluster tier, keep that the same. Additional settings, don't mess with that. And we don't even need to change the cluster name too. So create the cluster. You should be prompted with this security quick start. The super important thing you need to do is enter a username and password here. I always do Cooper and then codes. It's going to say I already have a name Cooper because this is already on my account, but make a username and password that you're going to remember. I suggest don't make it Cooper Codes. That's a very weak password, but just for these videos, I'm just showing you guys something simple. You also want to scroll down to your IP access list and make sure that this 0 thing here is in there. So just press add entry with these zeros. This is important because it allows any IP to access this MongoDB database. At production, you might not want to do this, but just in tutorial land, yeah, keep it at all IPs so you don't run into any strange issues regarding not being able to connect to MongoDB. Once you're done with that, you can just finish this up here. It might take a second, but eventually your cluster should look like this under database deployments. You're going to want to press connect. Then you're going to want to say connect your application. And this is the link that we need to use for Apollo server. So make sure to copy this link, save it somewhere. I'm going to mention it again in a second. But now that we have this link in an active database, we are good to go in regards to getting started on the Apollo server code. So let's get into it. All right, so let's get started by creating our basic file structure we're going to be using for the back end of our Apollo server. To get started, we're going to say npm init -- yes. This is going to initialize a package.json in our project. So we can now do things like create npm scripts. We're also going to want to have a server.js where our server actually starts from. So make sure you make a file called server.js. I normally go through the file structure one thing at a time, like code out the entire server.js, but in this video, I'm going to show you guys the full structure right away. We're going to have a models folder, which is going to keep track of all of our database models using mongoose. Then we're also going to have a GraphQL folder, which is going to simplify how we create GraphQL stuff. Then inside of the GraphQL folder, we are going to have another folder called resolvers. This is going to hold all of your GraphQL resolvers, which I will talk more about later in the video. Inside of the GraphQL folder, you're going to want to say typedefs.js. This is going to store all of our GraphQL type definitions. Then inside of resolvers, we're going to want an index.js. So this is great. We have all the files we'll need, and throughout the video, I will be explaining what every single file is and why it's necessary. So we can go back to our package.json, and we are going to make an npm script. So if we wanted to say npm start and run something, what we would do is go to these scripts here, add a start, and we want it to do something. So I want to run this server.js with node. So I'm going to say node server.js. This means whenever I say npm start in my command line, it's going to then run node server.js. For this project, we're going to only need 4 packages total, which is sometimes small for a project, especially, something like a URL shortener that's significant size. So we're going to npm install apollo-server, apollo-server-errors to make some error handling on our Apollo server. Then we want mongoose, which is going to hold our database models when interacting with MongoDB. Then we also want short ID, which is how we're going to create those shortened URLs. Now that we have everything set up, we can get into server.js and create the initial Apollo server and MongoDB implementation. We're going to start by requiring a couple of libraries here. So const Apollo server is going to be our first one, which you may have guessed is going to get us access to the Apollo server library, which is great. I'm also going to need mongoose, which I'm going to say const mongoose is equal to require, then the package, which is going to be mongoose in this situation. We can then say const mongodb is equal to an empty string for now. And so go and get that string I discussed earlier, the one in your MongoDB over here, copy this string, come back to your page, and then paste it in here. Then you're going to want to only change 2 things. The username should be replaced with your username. So if you copied me, it should be Cooper, and the password should be replaced with your password, which if you copied me is going to be codes. So now we have this MongoDB string we can use to connect to the MongoDB database. First, I'm going to require a couple things. The first require is going to be const typedefs is equal to require./GraphQL/typedefs. We're doing this because we need typedefs, the type definitions to our GraphQL, and then the resolvers to launch our Apollo server. So we need these const resolvers next, which is going to be equal to ./GraphQL/resolvers. We can now initialize our Apollo server by saying const server is equal to new Apollo server. This is the thing we introduced at line 1. And Apollo server takes a couple of parameters to get started. The first one is going to be typedefs. The second one is going to be resolvers. From this point, Apollo server handles everything for us. We just show it what do we want defined in our Apollo server and what do we want the resolvers to, fulfill, for example, which I will explain later in the video, of course. We then want to make sure that Mongoose is connected before we start the server. And so Mongoose actually helps us with that. Mongoose.connect allows us to attempt to connect to a URI string, which is the thing we have at line 4. So use that MongoDB const from before. And it's just like you would connect to like google.com if you were on a web page, for example, the same concept. And we want to say use new URL parser is set to true. This is just some stuff that's required by Mongoose. We're then going to say .then, which means once that is done, once we are fully connected to MongoDB, we want to add more logic on top of this Mongoose connection. So we can even say here, if we get to this point in the code, MongoDB is connected, which is great. And then we want to say, okay, from here, what do we want to do? Well, now we want to return that we want our Apollo server to actually start. We start the Apollo server by saying server.listen to port 4000. And by default, this is going to work on your local host. So if you've ever seen like localhost 4000, that's what this code is saying right here is go to localhost 4000 and listen for any request being sent to there. We can kind of think about the then statements as almost like catching the code. We connect, and once we're fully connected, we catch it and we want to do something else. Once we run server.listen and the server actually starts, we do another then statement. So we say, okay, you're running, we got you, this is great. And now that we're in the next then statement, we can then say, okay, if we made it this far, we can say console log server running at, this is some syntax from the documentation, but you can use this result and get the URL out of it. If you're curious as to what this result object is, it's something returned from server.listen in the Apollo server documentation. But if you're, let's say I don't want to look at documentation, you can always say something like console.log res, and it should show you some of the attributes relating to the result here, or the response, I should say. All right, and so this code isn't going to run quite yet. And the reason behind that is that this server right here, the type defs and the resolvers are not created yet. And so we're going to go in and kind of build the more backend heavy code to this project right now. So first things first, we're going to need a database model to store the URLs. And so this should start to make more sense as to how this application actually works. I can talk all day about having a little, PowerPoint presentation and showing how the arrows move around and like, oh, it makes sense logically. But now we can actually talk about what do we store in our database, for example, right? The first thing we're going to do is we're going to go into models and make a url.js to store this kind of URL database object. We're going to say const mongoose to say we want to create a mongoose object. And you might be kind of curious, like, what does it mean to create a mongoose object? Or in our example, a mongoose.schema. If we want to talk to MongoDB, one of the ways we can do that is by talking to Mongoose. It's kind of like the interpreter. It can be like, I want a URL database object with, 3 different properties and they're all strings. Okay, how do you actually say that to MongoDB? You create a Mongoose schema. So the schemas are the rules as to how we save things to MongoDB. And so we can say const URL schema, and I'm going to make it capitalized URL schema is equal to mongoose.schema. Because this is a constructor, we need to say new mongoose.schema. So important thing there. Don't miss out on that. And this mongoose.schema requires a definition, as it says in the little VS Code helper here. This definition is asking us, what are the specific things you want inside of your schema? Well, if we create a URL, I think it would be a good idea to see when was this URL created. Like if we're looking at, I'll make an example at the top. If we're looking at thecoopercodes.com. We might want to see when was the short URL for this thecoopercodes made. And so we can save that by using a date, for example. So we can say date is going to be a type of string. And we can also do things like defaults. So a default to date would be date.now in JavaScript, for example. And so you could imagine we want a couple different things. Another thing we might want to save is the original URL. So we're going to have the short URL ID, and we're also going to have the original URL, right? Because you could imagine if we have some ID like this, we wanted to eventually say, hey, you saved ASDF. Well, that is pointing to thecoopercodes.com. And so we can save both this thing on the left, the ID, and this thing on the right, that longer ID. And so the original ID in that example would be thecoopercodes.com. So we can go in here, we can save that as a string, and we also want it to be required. And so required true is important for here. And so we can also store the full short URL right here. And so I'm going to say type is string. Required is also true. We need a short URL. Then we're also going to make a URL ID. And so this is the ID that we would see like ASDF. And we're going to see, we're going to store this URL ID alongside the whole URL schema. So we're going to say type is equal to string. Required is true. An interesting part of this project to really show some like kind of backend prowess, for lack of a better word, is that we are going to keep track of the amount of clicks. So you could imagine if I made a short URL and I put it on the description of my YouTube page, for example, I might want to see how many of you guys clicked on it. And so we can save that by saying clicks. And so what do you think of when you think of clicks? Well, it has to be a number. So we can say type number, which is part of Mongoose. So these type numbers are the Mongoose types we're passing in. And then we also want it to be required. We want that to be true. We want the clicks variable to always be there. And we want it to default to a certain value. For example, default to the value 0. Because you're not going to create something and it has like, 100, clicks on it already, for example. And let's say we made logic where we were adding 1 click at a time. We want to make sure that that addition starts at 0, because it's kind of weird to think about. But if we didn't say default 0, where is it going to start from? It's a type number and it's required to be true, but it has no number. It has no number to start from. And so that's another interesting little kind of back-end way of thinking about it logically, is that we have to make sure this default is 0, so it has a number to start from. From Mongoose's perspective, if we don't say default 0, it's just like a number could be stored here, but right now there's nothing being stored there. So this default 0 helps us when creating logic like that. And so if we want the rest of our JavaScript application to be able to use this Mongoose model, what we're going to do is going to say module.exports, which is going to say if you're calling the url.js, what do we want it to show to the other files that are using it? Well, we are going to say, hey, if we export to a different JavaScript file, I want it to show the mongoose.model. So this is how we actually make the model. We're going to call the name of the model URL, and then the schema of the model, you might guess, is the one we created right here. So URL schema. And so this is great news. This means that we can now store all the data we need for certain URLs inside of our database. Now we have to get started on the Apollo server logic as to how we're going to actually code that out. So let's move over there. Kind of a huge point in this video is in typedefs.js, we want to show the type definitions of our GraphQL server and Apollo server. So we actually have to start coding in GraphQL. One way we can use GraphQL is by saying const, curly braces, GQL, is equal to require Apollo server. And if you're new to JavaScript and you're like, wait up, we just used require Apollo server somewhere else and it was getting Apollo server, right? Like for example, in server.js, we just used it over here and it's getting Apollo server out of the same require statement. How does that make any sense? What's happening is when you have these curly braces, there is a bunch of things inside of Apollo server. There's like thousands, I don't know. There's probably like, tens of things, for example, out of Apollo server. And you don't always want them all at one time, for example. And so when you use these const and then these curly braces, what you're saying is I want specific things out of the Apollo server package. So in this case, we specifically want GQL, the graph querying language, out of require Apollo server. And so that's an important thing to understand when seeing these curly braces next to require statements. All right, and then so in a similar fashion, we just talked about module.exports, but in the same way, we're going to do a module exports here. We're going to say, if we ever call typedefs or if we ever require typedefs, we want it to show the entire GQL typedefs we created. And so what you're going to do is you're going to say GQL, and then you're going to do some backticks. Within these backticks, your code is going to be processed as actual like GraphQL, like graph querying language code. And so we can start coding, not in JavaScript, but in GQL, which is pretty cool. The first thing we're going to do is create our single type. This might seem like a more complicated backend project, but we only really need one type. You can imagine we actually have one database model too. So it's kind of a more simple project. And so we're going to have a type that kind of mimics what we just made in our database model. It's going to store a date, which is going to be a string. And I'm just going to make some examples on the side as I code this out. So this could be like 0, 5, 12, 13, etc., something like that. We also need the original URL, which is going to be a string as well. And so let's align these up, make it look nice. It's going to be thecoopercodes.com. That's the original URL someone wanted to shorten, for example. We can also have the short URL, which is going to be a string. Oh my goodness, these comments are off. And so this is going to be like, let's say localhost 5000, or let's say like short url.com/ASDF. That's going to be our, ID, for example. Then we're going to have the URL ID, which is going to be a string. And just an example of this is going to be ASDF. That's going to be our URL. Then also clicks, which is just going to be that integer, which we initialized as 0. But let's say someone clicked the link 10 times. We want it to show like 10, for example. But I'm just giving those comments to give you guys an idea as to, what are expected values in this URL. And I'm kind of over explaining this one type just because it's going to be our only type in the application. That's all we need is just the URLs, right? Because after that, we're going to have the type query, and then we're going to have the type mutation. And so you want to use mutations whenever data is changing and queries whenever you're just asking for data where you don't change any of the data. For example, like if I just ask like, hey, what's your name? If you don't plan on changing your name anytime soon, that's an example of a query, right? It's like, what's your name? My name's Cooper. What's your name? My name is Cooper. 1,000 people could ask my name, and it's not like person 1's going to change my name and person 3 is going to change it back. It's nothing like that. That's a great example of mutations. You can imagine if a bunch of people are clicking on a website, you want all those clicks to be in order because you want the first person to change the 0 to a 1, the next person to change the 1 to a 2. And this is an example of like why you would choose to use a query versus a mutation. If you guys have any questions on that, always look up like GraphQL query versus mutation. There's always a bunch of great examples. So one simple query we can do is we're going to take the URL and then we're going to say ID is going to be equal to the ID type in GraphQL. And we want to return a URL. This ID is just going to be like our MongoDB database ID. We don't have a lot of queries in this application, and so I'm kind of just making a simple query because Apollo server requires at least one query in your server to be created. So this is just going to say, hey, look for a URL data type with a certain ID. But the mutations are where things get interesting. Kind of like I explained in the beginning of the video, we're going to have two different things. A visit short URL is our first one. We're going to take a URL ID, which is going to be a string. and we're going to want to return a URL. So if we were visiting a short URL, you could imagine that we are going to see if ID exists. If so, we add 1 to clicks and then redirect to original URL. And that's like a huge comment here, but it's kind of worth saying just to give you guys an idea of the functionality. But that's kind of what's going to happen in the backend code. So hopefully once we get there, it'll be really easy to understand. And then we also want to generate a short URL. You could imagine there's a website where it's like put in your URL, the one you want to shorten, and we'll give you a short URL. This is the great example of that. So you want to take in that original URL as a string, and then we also want to return that URL object of all the data around it. You can imagine I want to shorten google.com. I want to make a short URL of that for some reason, even though it's already pretty short. I'm then going to see, do we have a Google saved in our database? If not, then we're going to say, okay, make a ID to represent google.com alongside an object in our database. And so we want that object, like we're talking about up here, to represent google.com. And we also want to make an ID to be referenced so we can say things like, short url.com/id to then access google.com. And I'll get into that logic specifically in a second here. Hopefully these little comments are helpful. I always want to put an emphasis on you guys really understanding why I'm making the decisions I'm making. So if it seems like I'm over explaining, feel free to jump around in the video, of course. All right, and so this is all we need for our type definitions. And so resolvers are the things that resolve these little functions we've created at line 13, 17, and 18. It's like, what is the actual logic behind querying for a URL? Or what is the actual logic behind visiting the short URL? What is the logic behind that? That is what happens inside of the resolvers. So let's hop over to resolvers, and we're going to make a urls.js. This is to store all the resolvers surrounding the URLs. Inside of our index.js, we're going to create an easy way to wrap all of our different resolvers in our project into one single file. So for example, we're going to say const urls resolvers is equal to require./ which is our current directory, urls. And then going to module.export this. Okay. For all the queries, we want to then say, all right, get all of the URLs resolvers and get all the queries out of there. So we can make one big query object. You could imagine if we wanted to add more queries to this, we would say, okay, let's get the, users resolvers and add it to here. Let's get photos resolvers. And this is why this is a nice way to kind of manage your Apollo servers. All your queries can be in their own little files, but at the end of the day, you return this larger query object to your Apollo server to use. And the same thing goes for mutations. And one thing I didn't explain super well in a second here is that this ... is called the spread operator. And so what the spread operator is going to do is, let's say we have an array in this .query, resolver 1, resolver 2, resolver 3. The ... is going to then change this into just resolver 1, resolver 2, and resolver 3. All together. And so it's kind of taking it out of its array or out of its object, whatever it was previously stored as. It's then going to spread these into the query object here. And so you could imagine if urls resolvers.query had something, and then we had another thing called users resolvers. And users resolvers had resolver 4, resolver 5. What would happen is we would make a big list at the end of the day where all of our queries would be seen as this, all of our URLs queries, and then we could add on top all of our users resolvers as well. And so it creates one big list to kind of get sent over to our server. And that's why this is an interesting syntax to use. All right, and I'm going to get rid of the users resolvers here because we're not going to do anything with users. That's just an example as to why this syntax makes sense, especially if you're expanding your Apollo server project. Then the same thing goes for mutations. The exact same logic applies. So I'm going to kind of, skim over this, but the mutations, they're stored just like queries, except they're mutations. Big surprise. And the same logic applies where it's the spread operators doing the same thing because it's keeping all the resolvers and giving one large mutation block at the end. It should be module.exports. So make sure that this shows up as green. My bad. I'm going to make you listen to this for 5 seconds so no one misses this. Module.exports. It should not be module.export. That doesn't exist. So make sure it looks like this. All right, so here is the cool part. We can actually make some backend code now that we have everything set up. So we can go to urls.js and get started. Throughout coding our backend, you're going to have all the Apollo server code on the bottom here. And I never really saw this explained well in a lot of these Apollo server videos. If you want to use any JavaScript library in your backend, all you do is you say const whatever the library is and require it above your Apollo server backend code. That's how you use external libraries. And so I'll show you guys. If we wanted to use the URL object from the models, we would say require. Then we want to go backwards. Backwards again is what this // pretty much means go backwards in your files. Then we want to go to models and we want to go to URL. That's going to get us that URL that's being module.exported right here, for example. So we're going to be able to access this mongoose model that got created, which is pretty cool. Let's say in our backend, we want to use Apollo errors, which we do. We can say, okay, I want to use Apollo errors in my backend. So we can say const Apollo error equal to require Apollo-server-errors, which is super cool. And so now let's say we want the const short ID to create those shorter IDs. We can say require short ID. And so now we have, if we have any JavaScript code, so any code down here, we can use short ID or we can use Apollo error or we can use URL. And so that's why you have these require statements at the top is to kind of show like, hey guys, we're using short ID on this page. We're using Apollo error on this page. To explain to beginners, if you wanted to work with a new NPM package, for example, you would go and NPM install that certain package. You would look at what you would like look up like, okay, how does a require statement look like for short ID? Then you would put it at the top of this code. And then inside your Apollo server backend, you can use that code. You can use the code from short ID, for example. And all right, let's get into the module.exports of this Apollo server function here. So it's going to have two different things. It's going to be the mutation, and it's also going to be the query. Our query code is going to be so simple because it's just saying find a URL with a certain database ID. And so what we're going to say is let's look over at our type defs, for example. We have this query right here. And so let's bring it on over. Let's just copy paste it. Obviously, it's not going to copy paste like that, but let's just use it as an example. So we can say, okay, URL is going to be defined as this. Apollo server has a couple of parameters. The first one is the parent of what was calling this. We don't need to use parent, and so we say underscore is why we do that. Now it's going to be the parameters. Okay, we have the ID here, for example, so I'm going to say ID. This is going to get us this ID parameter here. That's all we need to worry about for now. We can create a simple arrow function pretty much saying for this code, use this functionality of URL. Remember, in this case, URL is our mongoose model. And mongoose gives us access to a bunch of different interesting mongoose, functions. And so if you look up like mongoose model methods, for example, you'll see a bunch of stuff of what I'm talking about. One of the more commonly used ones is find by ID. And it's going to say, okay, ID, pass it in there. Now, whenever we try and access this, we can enter a database ID, and we're going to look at all the database models of URL. And then we're going to ask it to see if there are any URL models that are of the ID. And this is going to return us the full model. And so our code's actually done. If you look at the resolver, we have the URL, we have the ID, which is our parameter, 100% good. Then we have the URL, which we're returning, which is going to become this object right here. This request right here is going to become a full URL if we find one. And so that's just a basic idea of the querying logic. All right, so now we have two different mutations we're going to create. I'm going to show you guys the create short URL first. And so I'm going to make it asynchronous. And so I'm going to say asynchronous generate short URL. Why is it an asynchronous function? Well, the first thing is that when we make calls to save or even find things in our URL, for example, we want to use await. So we can kind of, wait for those calls to be fulfilled before our code moves forward. That's the basic idea of thinking of it. And so we want an underscore to ignore the parent. And we also want to use these brackets to grab the original URL, which is going to be, if we look at our type defs, boom, our original URL right here. So generate short URL, original URL is our only parameter. So we're going to grab it like this. And then we're going to have all of the code is going to be within these curly braces. So now we can get into actually writing JavaScript code. I'm going to use a let. So I'm going to make some comments explaining the logic. First things first, we want to see if the URL already exists. That's first things first. If it does, show the user that current short URL. And I'm just going to use that example again of like, we don't want to store google.com 1,000 times. We don't even want to store 2 times. We just want one google.com stored in our backend, the short URL of google.com. And so we're going to just look for that, see if a URL exists by saying let URL equal await, because we're about to make a database call. So URL dot find one. So now we're going to find one URL, mongoose model, for example. One of these URLs is going to have a property of the original URL. And I'm just going to make this, because we said original URL, on our actual mongoose model here, I'm actually going to change that. And so hopefully this is going to be relatively straightforward, but I'm going to change this original URL here. I'm going to do this original URL here. And then also in our type defs, I'm going to change this to original URL. And also in the URL here, I'm going to say original URL. Hopefully that's not too confusing, guys. Sorry about that. If anything, it's going to help you understand all the different aspects of our code. So we create original URL here. We have it show up again in our type defs and in our type URL. And then we're going to have it again in the parameter here. I just wanted to make that naming consistent along all those. Sorry, I didn't realize that one of them was different. And so now we're going to show a constant, which is going to be the base URL of our application. So I'm going to say for this application, http://localhost 3000. This is a great time to say this is the URL to your front end. Remember, we're not creating a front end in this video, but this is just an example of if we were to be on, https://urlshortener.com, we just want this base URL here to kind of show. We just want to store these base URLs inside of our database based on like whatever you have in your front end. And so let's look back at this database call we just made. So if we do find a URL object containing this original URL, we have then found the URL object the user wants, the short URL for like google.com, for example. So if google.com already exists in our database, I'm going to say if URL return ID is equal to URL.id and then .URL._doc. This is just some stranger Mongoose syntax to kind of return the full, URL object. Because remember, this entire thing returns URL, the actual type. And so this return statement, you're going to see all over the place. This ID is our MongoDB ID, which is, to make that clear. And then this spread operator is getting all the other properties of our URL and returning those. So our return statement has access to all the different properties within URL. And just to give some examples, that's all these properties: the date, original URL, short URL, URL ID, and then clicks. ._doc is pretty much getting all of these and then giving it to that object there. All right, and so else here is super important. This means that the short link doesn't exist for the given original URL. So now it's time to create the short URL, and that's all caps because it's a super important part of this else statement. So first things first is we're going to make const generated ID. We want to make a new short ID. And so what we can do here is we can say short ID, which is a library we installed, .generate. And so this creates a unique string. And if you've never worked with things like, UUID, I would literally look up right now in Google, UUID math. Because the crazy thing about this is these .generates, they're not like passwords. You don't need to make them super secure. You don't even need any parameters to the generate. This is going to give us a short ID we can create for a certain, domain name, for example. And so the math on these is actually so impressive. There is an incredibly low chance. For example, let's take a look over at Nano ID, which is another kind of similar competitor to Short ID. We're not using this one in this video, but it's another example. Nano ID. It has an ID length of 21 characters. And if you were to ask for, let's say, 1,000 IDs per second, that's wild. It would take 41 million years to have a 1% probability of at least one collision. And so if you're confused at all as to why can we just say .generate, which is a valid question, it's because these IDs are surprisingly almost impossible to ever collide, ever, which is super interesting. I didn't even know about this in fully for a while. And it's one of the reasons why you have all these ID libraries so that you can just say .generate and boom. This is going to give us a string we can use for the short link. We can also give an example of what our short URL is going to look like. So for example, I'm going to use backticks to make variables here. The $sign and then the brackets is going to give us access to a variable. And so I could say base URL / generated ID. And so for example, this is going to show us something like https://urlshortener.com. If that was your base ID, if that was your base URL, then you'd say / your generated ID. So it's like ASDF. So it's just kind of storing that format for us here. We're now going to redefine this URL object up here. And so we can say URL is equal to a new URL. And so this is when we actually generate a object of data to store in MongoDB. So now we're going to tell Mongoose, okay, what exact data do we want to store in this URL object? Well, I want to store the original URL. I want to store the short URL. I want to store the URL ID, which is going to be equal to that generated ID that we just made above. I also want to store the date as new date. And so from line 24 to line 29 is just setup of our database object. If we actually want to go and save this object to our database, we need to say const result or response is equal to await, because we're making a database call here, url.save. This .save function is going to take whatever data we passed into the URL in this object here, and then it's going to pretty much save it for us to the actual MongoDB database. And so that is how we can communicate with MongoDB on an Apollo server backend. Now I'm going to return, same thing, and we can even copy it to show you guys it's the same. Return all of these different things from result right here. So the ID, that's the MongoDB ID, and then all the different properties that we get out of URL. And I'm just going to put semicolons at the end of these return statements just to make it look nice. And sorry, instead of url.id, this should be res.id and then res._doc. So that is the full code for generating a short URL. Now the easier part is going to be asynchronous because we're still going to be calling the database. We're going to go to the visit short URL. And so same thing, underscore, because we're ignoring the parent, and we're going to get the parameter. And so if we go back to our type defs, we can look at visit short URL here and see, oh, it's a URL ID like this. And so we can go back to URLs and pass in that parameter there. So you could imagine this is for a user visiting shorturl.com/ID_ here. So a user is visiting this. They could enter anything they want in the ID_ here section. So the first thing we have to do when they visit is check that they're actually visiting a real URL. So we can say const URL is equal to await url.find1. And we can say, I am looking for a URL model object that has the property URL ID, just like I have it here. That's what we're looking for. And so if the URL does exist, like for example, we do have a saved google.com link, we want to then redirect the user to google.com, which is actually something our front end does in this case, but we want to at least send that data to the front end. And so if the URL exists, first of all, URL gives us access to the actual MongoDB database model here. And so we can say url.clicks is equal to url.clicks plus 1. This allows us to use this url.clicks information that we've just gained from asking our server, does this URL thing exist? If so, we get the full URL object to work with, including all of its data. So you can say url.clicks, add 1 to it. But you hear this is something a lot of beginners mess up on though, is now we have to actually save that clicks. If we don't save it, how is our MongoDB ever going to know? It's only on our end we see url.clicks change. But if we want to say, hey, MongoDB, we actually made a change here. Can you update, please? We say const res is equal to await url.save, because it's taking this local URL object that we have, modifying the clicks by 1, and then saving that new URL object with that modified clicks. Hopefully that's a good way to explain that. And same thing here, we can even copy that from this. We're going to return that ID with a res.id and the new res._doc here. An important thing to mention here is this res._doc is going to contain the original URL. And so our front end can redirect user to original URL. And that will make sense at the end of the video when I show you guys actually calling this API and actually using it. You'll see all the information we get back from the API. And here's the thing, we're almost done with the backend code, which is great news. This else statement, you're like, we're almost done. Where's the Apollo server errors? Great question. We're going to throw an error where we can say new Apollo error, which is the object we grabbed from, let's scroll up right here, require Apollo server errors. And we are going to then make a unique error code that we can send to whoever's calling this API. So I'm going to say there is not a URL with the given ID. You could imagine if someone asks for like shorturl.com/a, and we have no IDs that have the thing A, we can send them this little error. They're still going to visit the short URL technically, but what's going to happen is it's going to be a URL that doesn't exist. And so I'm even going to add a code, URL not found. And so at this point in our code, we kind of developed this full system, which is actually pretty amazing. This is a lot of work to get done, and I would argue is a pretty significant backend system where you have to understand every single part. We should now be able to go to our terminal, go back to server.js, and we can say npm start. All right, so if your MongoDB connection string is working, you should see MongoDB connected. And then we should see server running at localhost 4000. All right, so now we can actually make a call to the localhost 4000. We can start by going to mutations and then generating our first short URL. So I'm going to press add to query here. Apollo Server makes it so easy to make these GraphQL queries. You literally just like click, okay, do I want arguments? Yes, because this argument's required. You want to use it. What do I want my original URL to be? I want it to be thecoopercodes.com. I want to add all the different fields, and this is the data that the GraphQL API is giving us back. So let's just say I didn't really care about the date. You could like get rid of that like that, for example, but I just want to see that all the information is showing back. So I'm going to go all in and look at all of it. So from this point, all we need to say is like, hey, could we generate a unique URL for the coopercodes.com? Let's try it out. And if you get a status 200 to your right here, that generally means that you got a successful request, which is great news. And so now we've been given this object. The important thing we want to look at this object is this URL ID here. And Apollo Sandbox is so cool because you can make a new tab, kind of like you're in Chrome. So make a new tab here. We want to keep this generate short URL. But in the new tab, what we can do is go to the mutations and then go to visit short URL. So press that plus there, and then we want to do plus to the fields and all the fields here, for example. We can now add in as a variable this URL ID we just created to almost visit that link. Whoa, and look at this. We get returned the full URL back. So you could imagine if you were to code a front end for this in React, for example, this object would go to your React front end, and then you could redirect the user to thecoopercodes.com. All the backend knows right now is this URL ID right here, but this short URL ID gives us access to thecoopercodes.com, which we can then redirect our user to, which is pretty cool. And also, look at how fast MongoDB is. If you want to keep on pressing submit operation here, it's going to keep processing all those different clicks. So you can imagine, I'm pretty popular. If I were to do a YouTube post, yeah, you could have everyone clicking on it and it would, look at this. It would keep going. Look at how efficient it is. It would still manage to keep up. And so you can really spam this as much as you want. We can go over to MongoDB Atlas right now and see this URL that we just created. So let's go do that. So you should be on this page. You should see that you've had, connecting to your own database. And yeah, we can actually go in here and we can say browse collections. And look at this. We have this URL object that we've created from our backend, which has all the information that we'd expect. And so if we want to go back over to our Explorer and make a new short URL, I would challenge you guys to think of something, I don't know, whatever URL you want to make short, for example. I'm just going to say bruh.com. Good name. You can generate a short URL and boom, you have 100% new ID. We can go over to our MongoDB. We can refresh this page and we can now see that we have the short URL for bruh.com. And so this is obviously very important. I think we should get NASA on this. Tell them that, I think humanity's peaked. And so this is a great example of how we have this full backend service working. And if we were to create another bruh.com, just to show you guys I ain't messing around, we actually have the logic for that too. So let's say I just created bruh.com short URL. Let's try and generate it again. I'm just going to spam this like 7 times. Do you see how the URL ID isn't changing? It's because we're not creating a new object. We're showing the same object that was created before. Yep, and it'll keep going. It won't mess up. I trust my code that much. And so let's go over to our MongoDB and see if there are like 13 bruhs that were created. Nope. See, it's just one ID, and that's actually going to make your database run way leaner. It's not going to have a bunch of different IDs and a bunch of different random stuff. It's just going to have the couple IDs you need for that. The interesting thing though is, let's say you wanted to create a service where someone wants to see how many people they redirected to youtube.com, and they actually want their own unique click count. Well, you could actually kind of work on the project I've given you guys so far and create that functionality, where you actually want people to create their own unique links. For this project though, I just want there to be one link, one website, and that's it. And so that's a really good example of how different backend services can be like tweaked a little bit to give you different functionality, right? And that is the full project. Thank you guys so much for watching. If you're new to backend development, or maybe you're a front-end developer looking at the backend for the first time, I really do hope that this video was helpful. And if you're interested in Apollo server content, maybe a video where I create a front end to this application, anything like that, feel free to subscribe. And if you've made it this far, I would really appreciate if you like the video as well. I know all YouTubers say that, but it legitimately does help my channel grow, so feel free to do that. Thanks so much for watching.